The Ground Systems Research Center of the Acquisitions Technology and Logistics Agency of the Ministry of Defense in Sagamihara City of Kanagawa Prefecture is in charge of the technical research and development of firearms, ammunition, ballistic and blast-resistant structures, vehicles, vehicle equipment, and engineer equipment. Its mission is to develop reliable defense equipment for the self-defense forces, including the Ground Self-Defense Force, and contribute to the defense and security of our country. In order to do so, it plans and executes necessary technical research on technologies with the aim of applying them to future equipment. Moreover, it is in charge of conducting technical tests to check the performance of equipment prototypes in technical development projects based on requests from the self-defense forces, including the Ground Self-Defense Force. The director of the Ground Systems Research Center, or GSRC, oversees approximately 100 personnel working for the Deputy Director, the General Affairs Section, the Systems Division, Ballistics Research Division, and the Mobility Research Division. So, let's take a look now at the research activities the GSRC engages in. Research activities. The GSRC conducts research that will lead to the development of next-generation equipment. Research on the remote-controlled engineering vehicle system for seaborne threats, with the aim of carrying out work in environments polluted by seaborne or chemical, biological, radiological, and nuclear contaminants, preventing people from entering them. A prototype unmanned remote-controlled tracked vehicle has been developed for research purposes. This research on these remote-controlled engineering vehicles was launched after the Great East Japan earthquake to enable safe and speedy responses to various situations that are difficult for people to handle after large-scale disasters involving radiation and other contaminants. These vehicles rely on satellites or relay units to remotely remove obstacles and open up roads, or obtain 3D images of the topography, information on gamma ray intensity, and infrared images, and so on, needed for the self-defense forces to implement their initial response. Performance checks on this vehicle system were completed in fiscal year 2015, realizing a system that is ready for use in disasters. With the aim of further boosting performance in fiscal year 2016, the research is being carried out on technology for integrating and displaying information from multiple vehicles. This will enable work to be carried out more safely and efficiently by multiple unmanned vehicles, even in outdoor environments where the topography and weather are variable. Research on the lightweight combat vehicle system. This research has been carried out on a lightweight combat vehicle system, which is lightweight and compact, yet has firepower, protection capabilities, and mobility. In research, tests have been conducted to evaluate firepower performance using a dual recoil gun. Blast-resistant tests have also been carried out using explosives to evaluate occupant protection capability of the blast-resistant vehicle. Mobility tests have been conducted on the electrically propelled vehicles with in-hull motors installed in all wheels. All kinds of data have been gathered through these tests. Furthermore, concept models of the lightweight combat vehicle system have been built on a computer, to which test data gathered from prototypes have been applied to boost the accuracy of simulations and assess the feasibility of the vehicle system. The results of this research are used in the development of armored vehicles for the Ground Self-Defense Force and applied to the research and development of future guns and combat vehicles. Research on hybrid propulsion systems. This study evaluates applicability of the hybrid propulsion systems to tracked vehicles. The mechanical power of an internal combustion engine is converted into the electrical power by a generator, and this converted energy drives electric motors in the series hybrid system. This hybrid system reduces acoustic and thermal signature of the engine and enhances the silent watch and silent mobility capabilities. It is also expected to improve fuel economy due to the use of smaller engines and electric propulsion. In addition, the power generation capability of this system allows it to be used as a power source of electricity by the troops. In this study, the Common Test Operations Procedure for Hybrid Electric Vehicles is also established as one of U.S.-Japan cooperative research projects, and it will continue the operation of hybrid electric vehicles for Japan, MOD, and U.S. DoD. Research on counter-IED systems. IED, known as an improvised explosive device, is a simple homemade bomb made from any explosives on hand and a detonator, among other components. In countries like Iraq and Afghanistan, terrorists target passing vehicles with explosives to cause major damage, making counter-IED systems extremely important to the self-defense forces in preparing for the carrying out of PKOs and other international cooperation activities. This system relies on radars and infrared camera sensors installed in a vehicle to detect IEDs, with the aim of implementing countermeasures such as diverting the flow of vehicles. This research is being carried out to improve IED detection technology by aiming to exchange technical information with the U.S., while miniaturizing sensors and integrating information from various sensors to allow installation in self-defense forces vehicles. Research on electromagnetic acceleration systems. Conventional guns rely on combustion gas from gunpowder to accelerate a projectile, but this research is being carried out on the railgun, which utilizes an electromagnetic force to accelerate a projectile. By using a massive current in excess of 2 MA, railguns in theory are capable of accelerating a projectile weighing 10 kilograms or more to a velocity of over 2,000 meters per second. The aim is to massively boost the range of the projectile and its accuracy compared to conventional guns. Research on generation electromagnetic pulses, or EMPs. Research is being carried out on ammunition capable of causing temporary or permanent suppression of internal precision electronic functions, such as sensor and information systems, to render them powerless by emitting powerful EMPs. Numerous sensors have been incorporated into equipment in recent years, in addition to the installation of precision electronic equipment. They are particularly indispensable in command communication and activities to gather information, making it extremely important to ascertain the effects and influences of EMPs on precision electronic equipment. This research is being carried out on the technology required to do this. Engineering tests. Engineering tests are the main part of equipment development. Various tests are carried out to see if prototypes meet the performance requirements, and technical tests are conducted to check their performance. Type 10 Main Battle Tank. The Type 10 tank is the latest and main domestically produced tank used by the Japan Ground Self-Defense Force. Engineering tests carried out on it include tests on firepower, defense capabilities, and mobility. Driving tests to test mobility, acceleration, maximum speed, braking, and turning were carried out, in addition to submersion mobility tests for fording rivers. Furthermore, firing tests were carried out using armor-piercing projectiles for tank guns. The Type 10 tank, developed through these tests, was completed in 2009. And is a state-of-the-art domestically produced tank, which has been deployed throughout the ground self-defense forces to ensure the security of our country. Type 16 Mobile Combat Vehicle. The Type 16 Mobile Combat Vehicle, or MCV, having outstanding mobility and air transportability, was developed with the aim of destroying enemy armored fighting vehicles and personnel with a heavy caliber gun. Engineering tests conducted during development included firing stability tests, rough road driving tests, slalom driving tests, and so on. Moreover, firing tests using heavy caliber guns while moving and dynamic response tests when the vehicle is subjected to vibrations were carried out. Through these tests, the Type 16 Mobile Combat Vehicle was completed in 2015. It has outstanding mobility, allowing it to be driven on expressways and transported by airplanes, while being equipped with powerful guns. It has been deployed throughout the ground self-defense forces to ensure the security of our country. Technology cooperation. Rapid progress is being made in a variety of technologies. In conducting technological research, the GSRC engages in active technology cooperation, such as through cooperative research, exchange of technical information, personnel exchanges with domestic national research and development agencies, universities, and various overseas research institutes, such as those in the U.S., to ensure the efficient use of limited time, budgets, and human resources. Cooperative Research Project with Chiba University. As cooperative research projects with domestic organizations, a study to enhance power density and reduce fuel consumption for future high-powered diesel engines is being carried out with Chiba University. Cooperative Research Project with Kyushu University and Teikyo Heisei University. GSRC has been conducting a cooperative research project with Kyushu University and Teikyo Heisei University to establish a technology to integrate highly sensitive explosive identification methods with unmanned systems in order to safely and quickly identify explosives. GSRC has also been conducting many cooperative research projects with other institutes in Japan. A cooperative research project is being carried out with the U.S. Army's TARDEC to establish a common test operations procedure for hybrid electric vehicles as the U.S.-Japan Cooperative Project. Another program is the Engineers and Scientists Exchange Program, or ESEP. This program aims to promote mutual understanding and cooperation between Japan and the U.S. through exchanges of engineers and scientists to allow them to experience the work of mutual counterparts for a set period of time. Cooperative Research Project with the Defence Science and Technology Laboratory of the UK. This research is being conducted with the Defence Science and Technology Laboratory of the UK on the technology to assess vulnerable areas in the human body under ballistic impact. In this way, technology cooperation initiatives are being implemented with various institutions. Test facilities are indispensable in carrying out such research and development. The GSRC has advanced test facilities to carry out research and development on reliable and superior equipment and test their performance. Power Simulator for Vehicle Powertrains. The Power Simulator for Vehicle Powertrains evaluates powertrains by simulating driving resistance on the engine and powertrain while the vehicle is in motion. Vehicle Static Characteristic Test Bench. There is a Vehicle Static Characteristic Test Bench for measuring vehicle static characteristics such as weight, center of gravity, and maximum safe incline angle. Environmental Testing Chamber. In the Environmental Testing Chamber, environmental performances of ground vehicles, engineering equipment, etc. can be evaluated under various temperature and humidity conditions. Mine Detection Test Facility. The Mine Detection Test Facility is used to test mine detection systems under constant soil conditions. Off-Road Simulator for Tracked and Wheeled Vehicles. The Off-Road Simulator for Tracked and Wheeled Vehicles evaluates dynamic responses of chassis and turrets by vibrating vehicles. Fuse Impact Simulator. The Fuse Impact Simulator simulates the various types of extreme shock that a projectile is exposed to upon using high-pressure gas to fire it. Powder gun. The powder gun accelerates a projectile by using the high pressure generated by gunpowder combustion. Two-stage light gas gun. The two-stage light gas gun accelerates a projectile with the pressure of hydrogen or helium compressed by gunpowder combustion. Supersonic wind tunnel. Continuous operation wind tunnel testing measures the aerodynamic forces acting on flying projectiles in the early stages of designing artillery shells. GSRC has numerous facilities that are only found here domestically, and they have become indispensable to the research and development of defense equipment. Historic sites. The land where the GSRC currently stands was formerly the site of the Weapon Academy of the former Imperial Japanese Army and the Sagami Army Arsenal. The Tank Road. This is One Green Road, formerly known as the Tank Road. Today, this road is a renowned cherry blossom viewing spot, but before the war, it was designed as a tank road, while after the war, it was used for test driving armored vehicles, until around 1965 under the management of the former Defense Agency. This is the monument marking the former site of the Imperial Japanese Army Weapons Academy. The school fostered experts in weapons technology, and it was established in 1939 within the extensive grounds that include the current GSRC, with the aim of promoting the mechanization of military equipment. It was attended by over 7,000 people, including students and instructors. Today, the spot is marked by this monument. This is the monument marking the former site of the Sagami Army Arsenal. Mainly weapons such as tanks and artillery shells were manufactured here. At the time, it employed around 13,000 people, including Army personnel. The history of the GSRC began in 1952. After the war, when the Technical Research and Development Center of the National Safety Agency was founded, which later became the research centers for the Japan Defense Agency, then the Ministry of Defense, before becoming a part of the Acquisition, Technology, and Logistics Agency. Today, the GSRC plays an ever-expanding role. To fulfill its duties of researching and developing technologies for reliable defense equipment, the GSRC ensures full appreciation of the need for equipment by the self-defense forces. That enables us to proactively offer proposals based on the technological knowledge and trends at the Research Center, while working in close cooperation with not only organizations associated with the Ministry of Defense, but also domestic and international research institutes. The Research Center performs daily activities to enhance technological capabilities, leading to advanced defense equipment. While fulfilling its duty, the GSRC will continue to play its part in the defense and security of Japan in the future.